Hello. In this video, I will be talking about ideal gas law. This is the third part of the behavior of gases. So, ideal gas law. We have always studied that the ideal gas law is nothing but the relationship given between all the properties of the gases, which is PV is equal to nRT. If you followed my previous videos, we already spoke about pressure, volume, temperature, and the relationship between pressure, volume, and temperature in gas laws. But what is N and what is R? And why are they in ideal gas law? How are they related? Well, before I talk about how are they related, first you have to know what is N law. N is nothing but the number of moles or number of molecules. This Avogadro's law gives the relationship between the volume and the number of moles. If you remember, you have something called Avogadro's number, which is 1 mole is equal to 6.023 times 10 to the power of 23 molecules. So he is the same person who gave the Avogadro's law for the gases, which gives that the volume and the number of moles are directly proportional to each other at constant temperature and pressure. So he has given the equation V by N is equal to constant, which is also written as V1 by N1 is equal to V2 by N2. So here you can see that if you are increasing the number of moles or the quantity of the gas, the volume of the gas is also going to increase. So now we know what is N and what is the relationship of N to the volume. What is R? Why did R come into ideal gas law? So before we study about R, as we are mentioning ideal, you have to know what ideal conditions are. So ideal conditions or standard conditions, if you watched my first video, you would be learning that standard conditions are nothing but standard temperature and pressure. So the volume of the gas can be compared at standard temperature and pressure because we know that the standard temperature is 0 degrees Celsius or 273.15 Kelvin and standard pressure is 1 atmosphere or 101.3 kilopascals. So at standard temperature and pressure, any gas of 1 mole occupies 22.4 liters of volume, and this is called as molar volume. This 22.4 liters is considered as molar volume because even if you fill it up with hydrogen, helium, oxygen, nitrogen, name any gas. So at constant temperature and pressure or at standard temperature and pressure, they are going to occupy same volume. So that is the reason this 22.4 liters is considered as molar volume. So now you know what are the ideal conditions. Now it's time for us to derive the R or the ideal gas constant. So ideal gas constant, we can derive it from the combined gas law. If you remember the combined gas law from the part 2 of the video, we know that PV by T is equal to constant. But when we introduce N into the combined gas law, we get PV by NT is equal to constant. So the combined gas law has no N in it. But since the Avogadro's law is volume is directly proportional to N, we are able to derive PV by NT is equal to constant. So this is a regular constant, but what happens at standard temperature and pressure? Because these are the ideal conditions. So the constant at the ideal conditions is called ideal gas constant, which is R. Okay, since it's constant, what is the value of R? So we can derive the value of R from this combined gas law by introducing N to it. So we know the constant or the standard pressure, we know the standard volume, which is 22.4 liters. We know the standard temperature and the number of moles, which is standard 1 mole. So when you substitute these values in this combined gas law with N, you get R value. So we have R is equal to 8.314 kilopascals times liters divided by moles per Kelvin. So if you remember, I mentioned about the units in my first presentation, because in ideal gas law, whenever you study anything about the gases or even in anything in chemistry, remember the units are very important, because just by changing the units, the value of R is going to change. So suppose, for example, you have this kilopascals times liters. If you change it to liters times millibar, the value changed to 83.14. If it's feet and psi, it's 10.73. So you know the units are very important whenever you solve any problems in chemistry. Gas law, which includes all the four variables P, V, T, and N. And that equation is given by PV is equal to N times R times T. But in real world, the ideal conditions doesn't exist. You know why? Because characteristics of an ideal gas is that it should not have any volume and there should be no attraction between the particles. Here, the particles means atoms or molecules. If you observe this figure here, the ideal gas law should have no intermolecular forces. You know, they should not be attracted and they should travel in a straight line. But in the real gases, there is always some attraction forces between them. Example, oxygen exists as O2, nitrogen exists as N2, and water vapor, it condenses back. Why? Because there is some kind of attraction forces between them. So, and for ideal gas law at low temperatures and high pressures. If you look here, the graph here is just shows us the relationship between the pressure and the ideal gas law. So if you look at the high pressures, you see there is a deviation from the ideal gas law. PV is equal to nRT. So when PV is divided by nRT, the value should be 1. But at high pressures, you can see there is a deviation of H2 gas, the methane, you know, there is a slight increase and decreasing, decrease and increasing. So, you know, there is always a deviation because the gases or the air can never have a constant temperature and a constant pressure. So that is the difference between the real gases and the ideal gases. So this is about the ideal gas law. We'll be talking about behavior of gases in mixtures and in movements. So the mixtures, I'm going to talk about Dalton's law, partial pressures, how are you going to measure the mixture of gases, and Graham's law, what is diffusion, effusion, and what is Graham's law of effusion. So this is about ideal gas law.